for us. I could not be any more excited. Happy. I have about 112 on this morning, Benjamin. The floor is yours, good sir. Just tell us who you are, what you do, a little bit about yourself, and then take it away.
Well, good morning, everyone. Thank you so much for being able to log in. I'm excited to be here with you. I'm the National Sales Training Manager for both the Goodman Amana and Daikin brands. And there's a lot of changes that are coming up in 2023. What I'd like to do over the course of our time that we have together is kind of talk about how we got to where we're at, and some of the things that you're going to have to be kind of anticipating as we begin to move forward with all of these changes that we're going to be talking about. So if you have any questions as we're going through it, I will try to monitor the various different chats and the question and answer features that are on here and make sure that we answer any questions that you do have. So let's jump right into the material and start talking about what is happening. So in 2023, there's several significant changes that are going to happen in our industry. And the first one I want to talk about is just the efficiency ratings changes. And we'll talk about where this all started and where it may be going in the future, even beyond 2023, as we continue to move forward. So back in 1992, if anybody was in the industry before then, we had no minimum efficiency requirements. Manufacturers could make whatever they wanted to make as long as it effectively cooled the customer's home. There were no issues that we had. Then underneath the Reagan and the Bush administration, there were a lot of challenges. If you remember, we were very concerned about energy independence. We were very concerned about there were rolling brownouts that we had on both the East and the West Coast, and they were looking at our electrical infrastructure. And it's kind of funny because we have those same questions and those same challenges that are coming up today. In 1992, the Department of Energy made a decision because of the amount of growth that we had in new construction and the infrastructure that we had for electricity and the cost to be able to put in brand new power plants, that they wanted to put some minimum efficiencies in place for our industry. So in 1992, the first regulation came out, and they said manufacturers were no longer going to be able to manufacture equipment that did not meet at least a minimum of 10 SEER. Then in 2006, they raised that minimum efficiency standard from 10 to 13. That was the single largest jump that we had in efficiency, and that was a 30% jump in efficiency. It also equated to about a 30% jump in price of the equipment. And so what happened was a lot of contractors, a lot of distributors, and even manufacturers produced as much 10 SEER equipment as they possibly could. And the distributors held on to that equipment. And we saw 10 SEER equipment continued to be sold through 2006, 2007, even all the way into 2008 and 2009 because of the amount of inventory that was built up. The Department of Energy wasn't too keen on that happening, and so they started to look at some of the loopholes that our industry had and started to think about how they could change or impact that. In 2015, before, we just had one efficiency standard for the whole entire country. In 2015, they then created regions within the United States. And so we saw a Southeast, a Southwest, and we also saw a North region. And in the Southeast and the Southwest, they actually moved from that 13 to 14 SEER in the Southeast. And in the Southwest, they added an EER requirement as well. In 2023, the federal government is going to be increasing the efficiency standards again. And so in the North, they're going to go from 13 to 14 SEER. And in the Southeast and Southwest, they're going to be going from 14 to 15 SEER. The big change that they're making here is this is not going to be just an enforcement at the manufacturer level, but they are also going to be making this an enforcement at the contractor and the installation level. And so this is a really big deal as we start to look at this, as they move this forward and they have this change where the contractors are now going to be responsible for being able to address that situation. So that means that there's going to be, when we look at this, contractors are going to be responsible for putting in AHRI rated systems. And one of the things that I like to look at, okay, whenever there's a regulation or there's a rule, we have to look at two things. How are they going to enforce it? And what's the consequences for non-compliance? And so the enforcement strategy of this is going to be through a hotline. And, you know, where it looks like that will probably be most utilized would be if you had an employee that was maybe disgruntled or unhappy, and they decided to report their employer for not putting in AHRI rated equipment, or if you had a customer that looked at their system and said, I don't feel like this is going to be, I don't feel like they gave me the right efficiency, and so they might report them, or a building inspector, or you could even have a competitor turn in another contractor. And so that's how the enforcement of the standards are going to take place, is through a hotline. What are the consequences that could be in place? There's a couple of different things you can look at it as far as consequences. Best case scenario, the Department of Energy could come out and have the installing contractor at the installing contractor's own cost, take all the equipment out, and then have to put in the correct equipment that was going to meet that minimum efficiency standard, again, at their own cost to correct the situation. Worst case scenario, there are some rules that are out there, and who knows if they'll ever, you know, go to the full extent of it. But the worst case scenario could be looking at up to $43,000 per day that piece of equipment is in operation, that the installing contractor could be responsible for. There's also some other things that are a little bit different. The way the rules are written, if a distributor knowingly sells to a contractor a system that they know is not rated, and they believe that contractor is going to put in a non-rated piece of equipment, the Department of Energy could actually revoke the privileges or the rights for that distributor to sell refrigeration equipment. And so that's going to have a lot of implications from the distributor side of things. And for a manufacturer, if the manufacturer knowingly sells equipment to a distributor that they knowingly know is selling to contractors and are putting in matched systems, that could also be something that they could come back and they could revoke that manufacturer's right to be able to produce refrigeration equipment. So there are some pretty steep consequences that are involved here, and it's something that everybody needs to pay attention to as we continue to move forward with this, because this means that things are going to be done differently. It means that you're going to see contractors are not going to be able to do high side changeouts. They're going to have to change the indoor coil with the outdoor coil. If that was it, if that was the only challenge that we had, then we can see, you know, we'd be able to get through this. But that's not the only challenge that we have. We also have some challenges that are going to be coming in place with the way that systems are rated. So in 2023, HVAC manufacturers are going to be required to comply with brand new testing procedures that to develop the efficiency ratings that we're using today. And when we compare today's test procedures with the new testing procedures, it really does help get the equipment to be more real world and more how it acts in the field. But it could create some confusion within the industry because of how these new testing procedures are labeled and how they will be presented to homeowners that are out there. So in 2023, we're going to be changing from the M testing procedure to the M1 testing procedure. That'll give us higher static pressures. And so we're going to be going from 0.1 inches of static pressure, which I can't think of any residential ducted system that would be at 0.1 inches, to 0.5 inches of external static pressure, which is much more in alignment with the way that most systems operate today. The default motor watt for each system. On our coil only matchups where we don't have that indoor air handler or you don't have that indoor furnace, is going to be assumed and go from 365 watts to 441 watts. And so that's going to have a big impact on your coil only matchups, meaning that you potentially are going to have larger coils and you're also going to have fewer matchups, which could mean that you're going to see more full system sales with either an air handler in an outdoor unit or having that furnace, coil, and outdoor unit to be able to get the matchups that you need and to be able to fit all of the equipment into the space that you're trying to fit it into. On the heat pump side of things, they're taking the heating load that began at 65 degrees and they're dropping that down to 55 degrees, which is more in line with the average of what the temperature of North America is, but that impacts our HSPF. This next slide that I'm going to show you, I think really helps to illustrate, what this new testing procedures, what the implications are. So we go from a 16 SEER system to a 15.2 SEER 2 system on a ducted system. What's interesting, if you follow along, you'll see a ductless system that is rated at 16 SEER today. If it's cooling only, would continue to be 16 SEER. And that's because the change was in that external static pressure, and we don't count external static pressure for a non-ducted system. When we take a look at HSPF, if you follow along with the 9 HSPF, the ducted system would drop down to 7.7 for an HSPF 2, and the ducted package system would be about approximately 7.6, where the ductless system, because of that change in the temperature from 65 degrees to 55 degrees, is going to drop down to 8.6. And so you can see how this correlation happens. So as we release SEER 2 equipment this year, you're going to have some scenarios where a contractor could be going out to a customer's home and one contractor could be quoting a 16 SEER system and another contractor could be quoting a 15.2 SEER system. And they have to explain to the homeowner that these are the same, approximately the same efficiency. And so that's something that we're going to have to work with, and we're going to have to continue to make sure that the consumers are educated, as well as all the technicians in the field as we continue to move forward. So when we look at the regional efficiency standards in the north, you can see the AC splits and AC package units. The new minimum requirement is going to be a 13.4 SEER 2. So they're moving from 13 SEER, where it was originally going to be moving 13 SEER to 14 SEER. We now move from 13 SEER to 13.4 SEER 2. In the Southwest, we're going to be going for everything less than 45,000 BTUs will be 14.3 SEER 2 with a minimum EER of 11.7 EER 2. Or if it's greater than 45,000 BTUs, we would have 13.8 SEER 2 that we would have available. In the Southeast, you're going to see that systems less than 45,000 BTUs would be 14.3 SEER 2, and systems greater than 45,000 BTUs would be 13.8 SEER 2. And there is no EER requirement in the Southeast. It's really important to note that heat pumps are going to fall underneath a national standard. And so for our heat pump split systems and our heat pump package units, you're going to be looking at 14.3 SEER 2, no matter where you are in North America. And the heat pump package unit is going to be 13.4 SEER 2 with an HSPF of 6.7. So all manufacturers, when we get to 2023, are going to be required to be producing SEER 2 product. And I'll kind of show you the next chart here that will hopefully explain, what is happening. And so these are cooling only systems that I have here. And when I look at any equipment that is built before 2023, you'll see on the left-hand column, they can be SEER, and SEER 2 is okay to sell before 2023, but that would have to meet the minimum efficiency requirements that we just went over for 2023. Any equipment built after 2023 that has a SEER rating will be illegal to sell in the United States. And so that's really important to understand as well. Right now, all of the testing test and third-party independent testing facilities in North America are booked up from now until the end of the year. So if a manufacturer does not have their time slot booked, they're not going to be able to get those ratings until after 2023. I think most of the US-based manufacturers probably are going to have their time booked. We're really lucky as a manufacturer with our new facility in Waller, Texas. We have 12 of our own testing chambers here that we can do all of our independent testing, and it is rated through AHRI. So that puts us in a really good spot. But any equipment built before 2023 that has a SEER rating, we're just going to follow the standards that we have today that everybody's used to. If we're installing after 2023, you'll see that you will no longer be able to sell SEER 13 equipment or all the way down to our 16 SEER equipment. So in the Southeast, you'll only be able to sell the 18 and above. In the Southwest, you would only be able to sell the 18 with the EER, minimum EER requirement and above come January 1, 2023. And you will have to have the AHRI matchups, making sure that it meets the minimum efficiency that it needs. For those of you that are selling package units, you can see that we don't have as many concerns. The North, you'll be able to sell everything. The Southeast, you'll be able to sell everything. It's just the caveat of the 15 CER or EER that we have without the EER that you will not be able to sell in the Southwest with that EER requirement that we have. So I hope this kind of makes some sense as far as what can and can't be sold as we continue to move forward. The only reason I put this slide in is to say all of the manufacturers got together. And so you had Carrier, Lennox, Trane, Rheem, Goodman, Amana, Daikin. We all got together. We all went to the federal government and we were trying to find ways in different scenarios. Because when this comes to the multifamily markets or even the new construction market, with all of the supply shortages for construction and the construction delays that are out there, you could have jobs that were bid with SEER equipment. But come January 1, 2023, if that equipment is not installed, and the definition of is installed means that it is brazed and the unit has power to it, then you will not be able to put in that SEER equipment in all of the regions that I just talked about. You would have to move to the new SEER 2 product, which is going to have some cost ramifications to it. If that wasn't enough for all of the changes that we have coming, the Consumer Protection Agency also came back and said, hey, the spacing on the top of your units is too wide, and we're afraid that kids are going to be able to get their fingers stuck in top of the units. And the challenge with that is whenever you tighten up the spacing on a grill, you restrict airflow. And so the only way to move the same amount of air through that same grill is to increase the surface area of the equipment that you have. So one of the things that we started to look at was we're going to be adding a Venturi ring to all of our equipment in the future. And so that actually gave us quite a big performance boost on all of the equipment that we had. But we're also going to see that the footprint of the equipment is going to have to increase as well in some cases in order to accommodate the airflow that we need to get the efficiencies that we need as we continue to move forward. So some of the things we did as a manufacturer last year is we started to release our 9-speed tap gas furnaces. The primary reason for doing this was to increase the number of speeds that we had available so we could get the new efficiencies that we needed. We also designed the aluminum fin coils in anticipation of all of these changes in 2023 so that we didn't have to get larger coils and we were going to be able to keep a good coil in place. We feel this puts us in a really good space because the only equipment changes that we're going to have to make for 2023 are going to be the outdoor units and the air handlers. We've already addressed the concerns with the furnaces and with the coils that we have. With all of this being said, there are going to be some cost impacts that everybody's going to have to be aware of. And so, you take a look, we're going to need larger compressors in order to get the efficiencies that we need. The condenser fan motors are going to have to move more airflow with higher statics and use less electricity in order to get the efficiencies. So there's going to be some changes in the motors that you're going to see. And you're also going to see a lot more factory installed TXVs on the coils. So just those component changes are going to impact the cost of the units in order to get these different requirements that we need. We're also going to see more commodities are going to be consumed by the larger units that we have. And we know that commodities right now in our current climate environment, the pricing for commodities is very volatile. But when you look at, the implication of the fan and the footprint of the unit, today 70% of our AC and heat pumps are on 26 and 29-inch chassis. In 2023, 60% of our equipment will increase to that 35-inch chassis. From a logistics standpoint, in our warehouses and our distribution hubs, we can carry 6 26-inch units on a set of forks. We can carry 4 29-inch units. We can only carry 2 of the 35-inch chassis units, which means we're going to need more people to move the equipment around. We're going to need more floor space to hold the equipment. But probably the biggest component that we're going to have in terms of cost is shipping. In order to ship the same amount of equipment that we ship today, what we can ship in one container is now going to take 1.5 trailer loads. And when we already have a shortage on the available containers and the available drivers to move equipment around, this is probably going to be one of the biggest impacts of all of the 2023 regulation changes that we have coming up that we're going to have to make sure that we address and we take care of for everybody that's out there. So I just want to take a look, and this is a very similar timeline for all of our Goodman, Amana, and Daikin products that we do sell. As far as what our timelines might look like right now, again, everything is subject to change. But when we take a look at things, we're probably going to be phasing out a majority of our legacy products in August of 2022. And then we've already started production of our CR2 products back in April. And so we're getting ready to start releasing that out into distribution. So you should start seeing our new models that are coming out. The reason we're phasing out a lot of the equipment in August is because we're going to be able to have enough inventory to last us all the way through December by having our last run go in August. If you take a look at the South, going back to the other chart I had talked about, the GSX-C16, the GSX-16, the GSX-14, those products are no longer going to be available for you to be able to sell in the South come January 1 of 2023. What you will notice though is the heat pumps, all of the heat pumps, because they're under that national standard, can continue to be sold through. One of the strategies I'm hearing from a lot of HVAC contractors out there for the multifamily and the new construction projects that they're running into is that they are moving those products over to heat pumps instead of straight cool systems, so that they don't have to worry about if they're going to be able to supply the products that they need. However, contractors will have to get that equipment and can't wait to get that equipment because we are going to stop the production of that equipment in August of some time. And so if they don't have the equipment by a certain time or have the order in, there's a high probability that they'll be switching over to the new SEER 2 product, which could have some cost impacts that I just explained with the new product that's going to be being released that may not have been accounted for in that particular project. I do always like to pause and say, you know, I don't think this is our last efficiency change that we're going to have. And I think this map really helps to understand where North America fits in with the rest of the world. If you look at Japan in 2009, 100% of the equipment sold in Japan was inverter driven. Oceania in 2018, 100% of their equipment. And so that's Indonesia, that's Papua New Guinea, New Zealand, Tasmania, Australia, Malaysia, all of this area, 100% of the equipment sold there was inverter driven. In China, we see 76% of the equipment in 2018 was inverter driven, Europe 84%. And then we take a look at the United States, and we're sitting at about 16%. So we believe the next efficiency change that we have is probably going to really drive more towards that inverter technology to help save the energy and make sure we can continue to maintain that energy security that we look for as a nation with all of the power that we're using for all of the other various things that we have. What I can tell everybody, if you're not getting our product marketing news, I would, talk to a local rep, make sure that you're getting all of our PMNs, because we're going to be continuing to send out more and more information as we go out this year. And I want to make sure that everybody is aware of all of the product changes that we have coming. What does this all represent? This represents about a 7 to 8% increase in efficiency overall. 70% of the equipment sold in North America today is not going to meet the new minimum efficiency standards. And 100% of all the equipment that's going to be sold in 2023 has to be retested and have that SEER 2 rating in order to be sold once we come into January 1 of 2023. So now we're going to just change gears here a little bit. And before I get into refrigerants, I'm just going to take a look at some of the questions that we have here. So will there be an update for long line set applications? Absolutely. As the new product is released and we put that out, we'll make sure. And again, that's where those PMNs are going to be very important for you to pay attention to, so that we have that available for you. For commercial projects, say a 22-story multifamily home project using one-phase splits, half the building is complete by 12/31 and require the others on 1/1/2023 for this project. Again, like I said, if the equipment is not installed by January 1 of 2023, then it will be illegal to install in the Southeast or the Southwest. If you're using heat pumps, however, heat pumps would be okay for you to be able to do that. Or if you're in the North. So it does depend on where that multifamily project is. But if it's in the Southeast or the Southwest, come January 1, 2023, it would either have to be the legacy heat pump or it would have to be the new SEER 2 product. Do you have a newsletter we can sign up for? Yes, if you want to do that, I can get some information out to the group so that we can get you guys signed up into the newsletter, make sure that you're getting all of our available PMNs that we're sending out and you get all the information that we need.
I'm happy to send that out to the group, Benjamin. And typically everybody always asks for a PDF of the slides as well, if you're willing to do that. And then I did one other question came through that I erased already. Is the $43,000 fine per system was asked?
Per system, per day?
Per system, per day. Ooh, that's going to get expensive quick. And then a couple came through on the chat. Harold asked,
I've got the chat up here.
Okay.
So yeah, looking as far as the Energy Star, yes, Energy Star is going to be updated. And so those ratings will be changed as we move into the new SEER 2. You will not see, as far as I know right now, and again, everything's subject to change, but to the best of my knowledge right now, Energy Star is not going to change until January 1 when the new mandate goes into effect. And then we also have what will enforcement look like. So like I talked about, the enforcement is going to be through a hotline. So if you had somebody on a project that doesn't think the systems are rated properly, or if you had somebody that was disgruntled, an employee or a competitor, even a building inspector, I could see calling the hotline and reporting contractors or general contractors that are out there. So does Department of Energy have defined installed? Yes. And I had addressed that. So that is set, brazed, and the electrical is hooked up. So it does not have to be started, but you do have to have it set, level, and brazed. The refrigerant does not have to be released yet. And you do have to have power to the unit. That is the definition of installed.
Installed. I've got a couple for you before we switch to refrigerants, if you don't mind. All right, just
Absolutely.
on a scale of 1 to 10, how big of a headache has this been and will continue to be for the manufacturers?
Well, you can imagine right now, supply chain channels are not the most favorable for manufacturers right now at all. And so
Right,
we're
bad
dealing
timing, huh?
we're dealing with a lot of the supply chain issues that are happening, where you have, big major manufacturing cities being shut down due to the pandemic that we're in, such as Shanghai. You have a war that's going on.
Yeah.
And, a lot of people don't realize that most of all of the neon gas that is produced was produced in Ukraine. Well, that's how you print circuit boards. That neon gas is used for lasers. And then you also have, I think 80% of the world's nickel was actually produced in Ukraine. And so there's a lot of challenges that are going on right now without all of these changes. And so trying to switch lines over and make sure that we can get the production up and running of the new product versus keeping the legacy product going for everybody as well. It's been a very interesting time, to say the least.
Yeah, and I've been on the tour of y'all's Waller plant. That thing is something special, man. It's thoroughly interesting. Can you talk a little bit more, or just a 101 layman's terms, EER versus SEER? And then I was just curious why no EER requirement in the Southeast.
Well, I think when you look at the West, you typically have a little bit more stringent enforcement. And so EER is going to be your real-time efficiency rating. And so there's no seasonal component to it. EER is when you have the unit up and running, you're measuring the wattage of the unit, and you're looking at the BTUs that it's producing, and that's how you calculate EER. SEER actually takes in, okay, we have different loads that are going to be on the building at different times, and we have that seasonal component to it. And so it just adds another layer to it to give you more of an average efficiency over a period of time, versus EER is the real-time efficiency at that particular point in time when you're standing at the unit.
Great, thanks.
All right, so let's jump into refrigerants. And again, I want to just give a little bit of background about the refrigerants, how we got to where we are today, and where we feel like we will be continuing to go as we move forward. So refrigeration and comfort cooling was first invented back in 1856. And when we take a look at the residential spaces, there was a couple of different things that people were looking at. But people wanted to be comfortable in their homes and wanted to have that movie theater experience that they had experienced brought into their home if they had the money to be able to afford to put it back in. But a lot of you that are in this industry are probably familiar with Montreal Protocol, which came into place back in 1987. The reason the Montreal Protocol was put in place, if you remember, anybody that was in school in the 80s, maybe the early 90s, you probably heard a lot about the ozone layer, and you heard a lot about the greenhouse effect. And the reason was the Reagan administration was looking at a lot of the challenges that we were having. And the ozone layer protects us from all the harmful UV rays that come from the sun. If you had no ozone layer, actually those UV rays would come in and they would destroy any living organic material. So not only do they cause skin cancer for us, but they would also destroy all of the living cells in the plants, which would mean that we would have no food source anymore either. And so it's really important to have the ozone layer, and that's why scientists were concerned. And the United States and a bunch of other countries signed on and said, hey, we have to do something about this. And one of the big things was to eliminate those gases that we were releasing into the atmosphere that destroyed the ozone layer. The interesting thing that we look at is since the Montreal Protocol has been put in place, we have actually noticed that the ozone layer has been repairing itself. And so it's getting back to where it used to be. We're back to about the same levels we had in the 1960s right now. And it's slowly repairing itself and becoming thicker and thicker, blocking out more and more of those harmful UV rays that we were worried about when they first realized that we were having a problem or an issue. The other big thing that they talked about in the 1980s was CO2 levels. And Dwight Eisenhower, during his administration back in the 50s, had put a testing chamber up on top of a volcano in Hawaii. And that testing sensor array that he put up there was designed to just measure the amount of carbon dioxide in the atmosphere. And in 2013, we hit 400 parts per million for the first time since that testing chamber has ever been put out there. And that was when all kinds of red alarm bells went off and everybody started to say, hey, we have to do something. And so what they're really concerned about is if we hit 1,500 parts per million, which seems like it's kind of far away, we're at 400 right now, but at 1,500, the surface of the earth actually becomes uninhabitable. And so we get two choices at that point in time. We can either all move underground, or we go find a new planet and hope Elon Musk is able to do that for us. And I don't think either one of those is a viable option. Chances are this is definitely not going to impact our generation, but it's the generations down the road that are going to have to deal with the consequences if we don't get something figured out. And so that's why the United States and 180 other countries all signed the Paris Agreement. And what that basically stated is we're not going to let the temperature of the planet rise above 2 degrees Celsius. Since the Paris Agreement was signed, the temperature of the planet has already raised 1 degree Celsius. And so now we're sitting at a point where we want to make sure we don't go 1 more degree. There was an amendment made to the Paris Agreement in Kigali to limit HFC emissions. The United States did not sign on to that because we did not feel that it was fair to the United States. And instead, what we did is we created what was called the AIM Act. And the AIM Act, on our own terms, actually talks about how we're going to phase out HFCs in order to reduce the impact that we have on those global warming or those greenhouse gases that are released. So this chart kind of shows if we did nothing, we know demand for air conditioning over the next 30 years is going to triple globally. As you see more and more countries come out of poverty, we're seeing more and more demand for air conditioning because people want to be comfortable in their home. And so if we did nothing and we did not adopt any of these change outs, we would see probably about a 10 times increase in the amount of greenhouse gases just from our industry, the HVAC industry. Our impact to the surface temperature change due to those greenhouse gases that we put out there would raise the temperature of the planet by another 0.5 degree Celsius. By putting in the Kigali Amendment and phasing out some of these HFCs, we can see that our impact can actually be less than where we are today. And so that's really the overall goal, was to see how could we limit the impact from the federal government. A lot of you that work with refrigeration in 410A today, you've probably noticed that 410A prices have been increasing, and they're only going to continue to increase because due to the AIM Act, we're going to continue to phase down HFCs in the United States. And so we have a really big phase down that's going to be happening. We phased it down just to 90% of production, and that is having an impact on price. In 2024, we phase it down to 60% of production. That's actually going to have an impact even on the units that are able to be produced, because there will not be enough new refrigerant. And so we'll need recycled refrigerant. And the big challenge that we have today is only about 5% of the 410A that's produced is actually recycled. And so that's a big challenge in figuring out where are we going to get the supply for these different refrigerants and these gases. But if we go and we take a look at the history of the different refrigerants that are out there, the industry started off with ether, alcohol, and ammonia as the main refrigerants that were used. And the challenge with those three refrigerants is they started to notice that there were fatalities associated with those in home residential spaces and property damage. And so in the early 1900s, the federal government decided to come up with a rating scale. And so for toxicity, they said A is non-toxic and that's okay to use. B is toxic, and you can't use that in a residential space for comfort cooling. And then they started to look at flammability. They said 1 is non-flammable, 2L is slightly flammable, 2 is flammable, and 3 is highly flammable. And so when we look at those ratings, we see that ether, alcohol, and ammonia, for one reason or another, does not check or make the requirements. So at that point in time, we moved to R11 or R12, and that was the refrigerant that we used. You'll notice that the efficiency of R11 and R12 is very, very similar to ether, and did a great job for us in terms of efficiency and what that does for us. But and it marks checks the box as far as an A and as a 1. So that was great. In the 1990s, then they started looking at ozone depletion value. We noticed that R11, R12 had a very high ozone depletion value. So then we transitioned to R22. And then from R22, that still had an ozone depletion value, we transitioned to 410A. You'll notice that the efficiency dropped quite significantly with R22. R410A got a little bit better, but it's still nowhere near where we were with R11 or R12. So in 2023, what they decided to start looking at was this global warming potential. And what they've mandated is they want us to get that below 750. So what does global warming potential mean? Well, if you look at R11, R12, 1 pound of R11 or R12 is worth 2,400 pounds of CO2. 1 pound of R22 is worth about 1,700 pounds of CO2. Then we went a little bit backwards with our 410A, and we went back up to 1 pound of 410A is worth about 2,088 pounds of CO2 in the atmosphere. So as a manufacturer, we made the decision that we wanted to go with R32. R32 has an efficiency of 164 BTUs per pound. Toxicity checks the box. It does happen to be a 2L, and so it is slightly flammable. And we'll talk about that a little bit and what that means. We look at our ozone depletion value. We're at a 0, and our global warming potential is at 677. So this slightly flammable, the first thing I want to get out there is it is not propane. It's not highly flammable. In fact, it is very, very difficult to ignite. You need to have a very high temperature, such as an open flame, to be able to ignite R32, and it does not sustain a flame. If you remove the flame source from it, it will extinguish itself. And so we look at that, and we know that that's something that we have to be able to make sure is going to be safe. And so I'll show you kind of
CO2 looks pretty promising from this table.
it would be, except for the pressures we have to run at. And so then everybody would be using hard pipe instead of a flexible pipe. It'd be a lot thicker that we'd be running, and the compressors would have to be a lot larger to compress the CO2 to get the refrigeration cycle to work, which is why, and that's what you have to weigh. You have to look at all of the different characteristics of each refrigerant and try to figure out what is going to be the best option that we have out there. I have a lot of contractors too that look at this chart and say, hey, ammonia doesn't look too bad. Doesn't look that bad, except for the fact we just had a leak in San Antonio not too long ago, and they had to evacuate a 10-block radius from where that leak was in a large commercial system. So, I mean, each one of these has their drawbacks that we have to look at, and you got to try to figure out what's going to be the best solution. So as a manufacturer, we decided to go with R32 as we look to get ready for this. Originally, we were going to go with R32 in 2023, but then we started to look at the building codes, and the building codes in most of the states out there would now allow you to install an A2L in a residential situation for comfort cooling. And so we're waiting for the building codes to catch up so that we're able to get this product out there. So right now, the EPA is looking at phasing down all of the HFCs and what that's going to look like. The kind of the stock tip that I give to every contractor is our 410A prices are not going to be going down. So that's a pretty good, strong investment for you right now. But there's a very high probability that it looks like what's going to happen is the US is going to transition chillers on January of 2024. And then we'll transition the residential HVAC systems on January of 2025. If we can get our 32 units out sooner, we will probably try to get our 32 units out sooner, depending on how the states adopt all of the building codes that are being written. I don't think we have anybody from Canada on this call, or do we?
No, I don't think we have any Canadians.
Okay, so I'm going to skip over. Basically, Canada was not doing any of this stuff, and they just have to follow whatever rules we're making here in the US. And so they kind of feel like they're being forced to do things that they weren't ready to do. But when we look at this, we don't believe global warming potential is the full measure, or will that be the last thing that we have to look at? And so we're trying to also anticipate where the next thing may be. And we believe that's really going to be in this life cycle climate performance. And so what this looks at is the energy used in a system over the lifetime of the system, and the direct impacts that you get from the chemicals that are in that particular unit. And so that's where you get your life cycle climate performance. And let me show you what that looks like. So in an R410A system, this is all of the greenhouse gases that are produced in association with the electricity that that system uses over the course of its lifetime. And then this is the impact on global warming gases that are put out due to direct leaks from that system. When you look at R32, you can see we have the same dark blue, the same amount of greenhouse gases from the electricity that the unit's going to use over its life, but it's the light blue that we're impacting. And so if you could impact the dark blue, that's where we say you have your biggest opportunity for actually being able to impact the total greenhouse gases that that system would be responsible for. And so that's why we believe that the next iteration is going to be really focusing on the lifetime emissions and looking at the efficiency of the unit coupled with the gas that is being used in it. And so we think that's really, really important for us to look at. So we announced R32, and we were the first manufacturer in North America to say this is the direction we're going. Shortly after we made our announcement, Carrier came out and said we're going to go with 454B. And so there's going to be multiple refrigerants as we move forward across the manufacturers. So far, Trane and Rheem and Johnson Controls have all announced that they're going 454B. And we're still waiting for Lennox to say, which direction that they're going to go. So to kind of give you a layout of what's happening in the industry. And what you can see with 454B is it has a slightly lower global warming potential. But one of the big things that we looked at was the efficiency. And so if you said 410A was 100% efficient, well then R32 is going to be 10% more efficient than 410A, and R454B is roughly going to be about 5% less efficient than 410A. When you compare those two, what implications does that have? Well, number one, we talked about the amount of BTUs per pound that a refrigerant could carry. That means we can use less refrigerant inside of an R32 unit than a 454B unit. And we really think that's important because you have to consider, how much gas as well as the impact that that gas has on the environment. And then you also have to look at, what can we do then with the raw materials? Could we potentially produce smaller units versus if you go to 454B, the units may be larger. And so because of this characteristic, we believe R32 and the efficiency and the capacity that it has, just for that reason, made a lot more sense for us to look at that in terms of refrigeration. The other thing is R32 is a commodity. It's being used in over 140 million different units in over 40 different countries, or by over 40 different OEMs in over 100 different countries out there right now. Japan started using R32 in 2012, and we saw Europe and India in 2013. And even in North America, if you walk up down the aisles of Home Depot or Lowe's, you'll see window units with R32 in them. So we're seeing R32 being used and adapted globally. That helps to keep the prices down on R32. And also when you have it open and it's a commodity and there are no patents associated with it, it makes it very readily available. And you don't have to rely on limited manufacturing or limited distribution. The other interesting thing, there are no claims of fatalities or property damage due to R32 being installed in a residential space across all of these countries and across, since it's been used. And so because of that, we really do view it as a safe refrigerant to be able to use. If you go to r32reasons.com, we've got a lot of reasons why we're looking at R32. If you want to educate yourself, I'll point out a couple here, and then we'll just get into the last round of questions. If you have any questions, please put them into the chat or also into the question answer section. Number one, it's pure, it's not a blend. That means you can charge in gas phase, you can charge in liquid phase, you can top a unit off. With 454B, it is a blend, and it does have a wider glide than 410A. So you may have to, if there's a leak in the system, recover the whole entire system and then charge from virgin. Also, you'll have to charge in liquid phase, not gas phase, as you put that refrigerant in, which is not always the easiest thing to do. So R32 is a lot easier to work with. It's very easy to install. It is also the main component inside of 410A. So it is something that everybody is already using. We also know that, there's Daikin has released all of their patents with the compressor technology and everything to make sure that all OEMs have the technology to be able to work with R32 and to be able to incorporate that into their systems. And we also know that it has zero composition change. It's proven, it's easy to recycle. And so please go to r32reasons.com, check it out. The big thing that we look at, we installed our first 2 R32 units last year, one in Florida, and then we've installed a couple since then, and then one also in the state of Washington. And so as states get their building codes in place, you can look for the Daikin Atmosphera and start using R32 to put into customers' homes and being able to use that. And so we'll continue to work to get those out to everybody else. So I got a couple of questions here in the question and answer section. What is the assumption in GHG intensity for electricity production in those calculations? So what they're looking at is 80% of the electricity is being produced by fossil fuels, if that makes sense. And then I've got a question. Does refrigeration efficiency change between ducted versus ductless system? So the refrigerant efficiency does not change. One interesting characteristic with R32 is in harsh conditions. So as it gets hot out, actually its performance gets better the hotter it gets or the colder it gets. And so as you get further and further away from the temperature that you're trying to produce from that unit, it actually gets more and more efficient. And so that's a great aspect that we have with it. So now I got, will I get a copy of this recording? One of the things I'm gonna have to apologize for is legal is not allowing us to put the PDF copies of this presentation out because we do have some sensitive stuff in here. I do think you said you're recording it, so I think you guys will be able to access the recording that we have out there.
Awesome. Yeah, that's fantastic. No worries on the PDF as long as I was talking to Shell, another employee at Daikin this morning, that guy that kind of a buddy of mine there. He's I forget his title, but so yeah, I'm gonna put it on our YouTube channel unless you tell me not to. And he goes, oh no, good, go for it.
Yes. And then awesome. So for R454B, yes, that is an A2L as well. And so all of the refrigerants that are being looked at are going to be A2Ls. And yes, R32 is a major component of R454B as well. What they were able to do is add another component in there that helped them get the GWP down, but that also impacted the efficiency of that blend that they're doing. So in comparing R32 versus 410A, if R32 is the main component inside 410A and it's more efficient, how did 410A become to be the refrigerant of choice? That was because it was an A1. They didn't want to go to an A2L. And so because we're trying to get to the lower global warming potential now, and that's the main goal, that's forcing us to look at A2Ls as the choice to move forward. I guess the biggest thing I keep trying to emphasize to everybody, again, this is not propane. It's not highly flammable. You could not put R32 in a torch and go braise with it. So we need to make sure that we keep everything in perspective as we're communicating with homeowners and we don't cause unnecessary stress for people. Like I said, it's very safe and we've seen it used in systems all across the globe and we're not having any issues with it. I think that's all of the questions I see, unless I missed one.
What, no, I had just one or two real quick.
Sure.
What happened? It just seems like that's going to be a competitive advantage for Daikin. I'd be curious to see what the other manufacturers' slide presentation sounds like, because it just seems to me like y'all made the right decision. But what happens? So obviously you've got to, HVAC contractors are going to have 2 different refrigerants on the truck now. Fun. I'm sure they're loving that. What happens when you put R32 in a 454B and vice versa system on accident?
So, if you catch that you've done it on accident, you are going to have to recover the whole entire system and then charge it back from Virgin. One of the questions that I know has been asked in a lot of these are they're going to be different size potential ports so that it kind of stops them from doing that. And the
That's a good idea.
answer that I've heard so far is no. And so everybody's going to have to figure out exactly, make sure that they double check what they're putting into the units.
Would the unit
And-
still work, just not work as well, or would it just not work at all?
The compressors are not designed for the wrong refrigerant. And so we have no idea what the performance of that unit would be once you change the refrigerant, what sort of BTU output you would get, or what sort of efficiency that you would get. Or are you potentially damaging that compressor because now it's running at different pressures than it was intended to or designed to run at. And so for all of those reasons, you want to make sure you get the right refrigerant into the right unit, and you can't mix or trade them. I've had a couple of contractors come to me and say, I love R32. Can I just change my manufacturer that decided to go 454B to R32 when we're in the field? And again, the answer is no. You have to use the refrigerant that that piece of equipment was designed for.
Wow. Wow. It seems like there would have been a trade group. It seems like y'all could have all just decided to get along and go with the, make the same decision. It just seems like these two different, I don't know. This is going to cause a lot of problems.
Well, we still really do believe that R32 is the right way to go. And again, that's
Yeah.
why I put the website out. And these are all the reasons why we believe it is the right way to go.
Yeah.
I think there's a hope that maybe some others will decide to change over as we get
Mhm.
closer and closer to 2025. I know everybody's focusing on these 2023 changes right now. And then 2 years after, we're going to be changing to different refrigerants. I can say Mitsubishi announced that they're going R32. And so, I mean, it's going to be a mess for contractors. They're going to have to carry R22, R410A, R32, and R454B. And they're going to have a recovery tank for each on their truck. So you have 8 tanks now on your truck, which is a lot to deal with.
Man, yeah, that's just, yes. Yeah. So anyway, well, Benjamin, that's just, I learned so much. Just a fantastic presentation. Well spoken throughout, great graphics, fantastic information. I absolutely cannot thank you enough. Very well done.
Well, thank you so much.
Yeah, no, great job. And those of you that need ICC CEUs, Kathy will send out a course evaluation. Just fill out the course evaluations. She'll send those to you. Yeah, just fantastic presentation. I'm glad I was able to catch you this morning. Since you didn't make it on your calendar, that worked out perfect.
Thank you so much.
Awesome. Well, thanks for joining. Oh, one more came in. Oh, no, just congratulating you, telling you it was good. Thanks for joining us this morning, everybody. Oh, hey, a best presentation I've seen comment. Wow. And we've done 100 different ones. So you can go ahead and take the rest of the day off, Benjamin. Just tell the boss I said it was okay.
All right, we'll talk to you later. Thank you so much, everyone.
Thanks. Bye, everybody.